Hello guys, today we are going to learn what is PN diode and what is working of it. So PN diode or semiconductor diode with applications too numerous to mention is created by simply joining an n-type semiconductor material with another type of material which is p-type material together. Nothing more, just the joining of one material with a majority carrier of electrons to one material with a majority carrier of holes. The basic simplicity of its construction simply reinforces the importance of the development of this solid state era. So at the instant the two type of materials are joined, uh, the electrons and the holes in the region the junction near the junction will recombine and resulting in a lack of free carriers in the region near the junction as shown in figure. Okay, so here the n-type material is joined with the p-type material, so the majority carriers electron in n-type material will recombine with positive carrier hole in p-type material near the junction, so the uncovered ion will remain near the junction. Here the negative ion and here the positive ion will remain uncovered. So this region is called depletion region. Why? Because this is depletion of free carriers in the region. This junction or this region is depletion of the free carriers. Okay, that's why this is called depletion region or uncovered region or transition region. Okay, so the PN diode can be operated as a reverse bias or forward bias, and simply if we don't apply any external voltage, it will be called as open bias. So this figure denotes the open bias. There will be no diode current because of absence of applied voltage. So if we applied some reverse bias as such that if we applied some voltage, external voltage, as such that the positive terminal of the external voltage is connected to the n-type material and negative is connected with p-type material, then it is called reverse bias. Then the number of uncovered positive ions in the junction will be increased because the electrons or majority carriers, which is electron in the n-type material, large number of electron will be drawn to the positive terminal of the voltage, and the large number of holes in p-type material will be drawn to the negative terminal of external applied voltage. So the uncovered charge will be increased near the junction. That's why the width of the junction will be increased. Okay, so there will be no current, there will be no significant current, there will be only some little current which will be in micro or nano ampere, which is called reverse saturation current. Why will it be there? Because there will be some magnetic carriers in n-type and p-type material, which is hole in n-type and electron in p-type. So hole in n-type will repel from the positive terminal of external voltage, and the electron in n-type will repel from the negative terminal of external voltage, and it will recombine near the junction. So it will form some little current that is called reverse saturation current, which will be in reverse bias. So forward bias, in what will be in forward bias? If you applied external voltage as such that positive terminal connect to the p-type material and negative terminal connect to the n-type material, then the majority carrier electron in n-type will repel from the external applied negative terminal of external voltage, and hole in the p-type material will attract from positive terminal of applied voltage toward junction. Then the hole in p-type will recombine with negative ion near the junction, and the electron in the n-type will recombine with positive ion in near the junction. So width of the depletion region will be decreased, and the passing of the majority carriers will be supported by the forward bias. Okay, because holes will flow to this direction, electron will flow to this direction, both will recombine, and the result in the forward current, large forward current, which we can see in current voltage characteristic in upcoming slides. So this is the current equation. id equal to is e power vd by eta vt minus 1. id is the forward diode current, is is the reverse saturation current, vd is the forward applied voltage, and eta is the ideality factor, which depends on the operating conditions and diode construction. Vt is the thermal voltage, which can be calculated as k into T by Q. K is the Boltzmann constant, which is equal to 1.38 into 10 power minus 23 joule per Kelvin, and T is the absolute temperature in kelvins, which can be calculated as by adding 273 in temperature in degrees Celsius. Q is the magnitude of electronic charge, which is 1.6 into 10 power minus 90 coulomb. And if you see the current characteristic varying with voltage, you will find like this. If you plot that equation, id equation, you will get this dash curve. Okay, but actually the commercial diode curve is like this in blue curve. So if you see, if you this is 0, if you apply 0 bias current, you will get 0 voltage. So this is that point. If you apply some forward bias voltage, you will get this characteristic, and if you apply some reverse current, some reverse bias voltage, you will get this reverse saturation current. So this is that reverse bias region. Okay, now if you see, if you apply large amount of reverse bias voltage, you will get a large reverse current. Okay, but ideally the current in reverse bias should be 0, and it is 0. It is very small, that we can consider it 0. But if you increase as the voltage across the diode increases in the reverse bias region, the velocity of magnetic carriers responsible for the reverse saturation current is will also increase. Eventually their velocity associated kinetic energy 1 by 2 mv square will be sufficient to release additional carriers through collision with otherwise stable atomic structure. That is an ionization process will result, whereby valence electrons absorb sufficient energy to leave the parent atom. Okay, if you increase the reverse bias voltage will increase 1 by 2 mv square, the associated kinetic energy of the charge carriers will collide with other carriers, and it will release them from valence band. So if you see the free carriers will be multiplied, so large amount of carriers will be generated, and large amount of current will be flown. Okay, but if you increase the doping level of p type and n type, so this breakdown is called avalanche breakdown. Okay, but if you increase the doping level of p type and n type material, this VBE, this avalanche breakdown voltage will become closer to vertical axis, it will become smaller in terms of magnitude. If it becomes minus 5 volt, then it is called zener breakdown. Why? Because if it becomes near to minus 5 volt, then what happens, then the electric field near the junction will come into the effect. So the electric field will act as another mechanism to which will help to break the bond of atoms, and will increase the free charge carrier, and it will contribute to the negative reverse bias current. So that is called zener breakdown. Okay, or zener region. Okay, so all slides we have discussed was silicon diode, but if we can made out PN diode with germanium, silicon, or gallium arsenide. So nowadays gallium arsenide is in much more use we are using it because of high speed and large breakdown voltage. So the knee voltage of germanium is 0.3 volt and silicon diode is 0.7 volt, and gallium arsenide has knee voltage 1.2 volt, but breakdown voltage of gallium arsenide is very high, 1000 volts, and for silicon 100 volts, and for germanium it is less, 50 volts something. Okay, so I hope you got the overview of the PN diode and you understood the what is PN diode and how it works, what is the characteristics, how it varies with uh, different materials, and how it the current varies with voltage. If you have any doubt, please write into the comment box. Thank you.